Okay, now we're going to be looking at a side-side angle situation where there are actually two possible solutions. Being able to spot these is really important, and here are some clues as to figuring out when you're going to have this. We have side A is 6, B is 8. So we know for sure, if I'm listing out some things in order, the A is 6. Okay, so angle A is going to be situated across from that. B is 8. Therefore, angle B will be bigger than angle A, which is at 30 degrees. Now, here's my question. Is B the longest side? Well, it's certainly not the shortest side, but, is angle C, does it fit in here, or does C fit in here? That is B the long side, or is B the short, or B the medium side? We don't know. Depending on where it is in this list, B could be acute if C is bigger. For instance, if C is down here, C would have to be could be obtuse. That would mean that B has to be acute. Or it could go the other direction, where B is actually the longest side and side C is somewhere in between here. That means that angle C is somewhere in between, and then angle B has the opportunity to be obtuse. We just can't tell. Therefore, we are going to find two separate solutions. And then on this slide, we are just going to look at the case that B is acute. So the natural thing to do is to look here and say, hey, I've got angle A, I've got side A, I'm going to start with that. So you start out with the fact that the sine of 30 over 6 is the sine of angle B over 8. Now, doing your cross multiplying and things like that, go ahead and pause if you need to. But in the end, you should get that the sine of angle B is the decimal point 6 repeating, which is 2/3. Now here's where the big thing is going to happen. And we're going to start out the next problem exactly the same way. But we're going to go the track that our calculator takes us this time. And when we say that angle B is the inverse sine of that decimal that you had before, 2/3, our calculator will tell us that it is about 41.8 degrees. All well and good. That just means that we have 41.8 degrees here, and then angle C is more than likely going to be bigger. In fact, we can just calculate it now. Again, notice that this is acute. That's all that our calculator will ever spit out to us. It's 41.8. Okay, so then we calculate for angle C. Take 180 minus your 30 minus your 41.8, and you get that angle C is about 108.2 degrees. Indeed, it is obtuse. And then you go ahead and run with that. Start over again with your angle A, so sine of 30 degrees over 6 equals the sine of 108.2. So now I'm working with angle C, so I'm finding side C. And I cross multiply, pause if you need to. And then angle side C, that is, should be about 11.4. So that gives us up here, let's see if I can take this and move it over so I have a nice spot. So then side C is 11.4. Double check. 30, 41.8, 108.2, everything's in order. 6, 8, 11.4 looks good too. Okay, so that's what happens if we just go the normal route, and that's what you're likely to come up with. If you're not paying full attention, you'll get that, but not this next one. Okay, notice how the picture is just a little bit different, but it's going to be labeled exactly the same way. Let me make sure I didn't even label this one this time, as this was 6, this was 8, and that was 30. Okay, so let's label this one. This was 6, this was 8, and this is 30. Notice that they are labeled exactly the same way, but oh, where is B? It moved a little bit closer. And now the angle at B is obtuse. So there's a picture of what's going on. Now this is going to start out exactly the same way. You're going to start out with the fact that the sine of 30 degrees over 6, working with angle A and side A, is the sine of angle B over 8. So again, we cross multiply, and we're going to get back to exactly that same point that we had before, that the sine of angle B is 0.6 repeating, in other words, 2/3. Now, here's the big question. What obtuse angle has a sine value of 2/3? Now, our calculator is going to tell us that we have an angle measure. When you do the inverse sine of 2/3, just like before, it's going to tell us that familiar 41.8 degrees. Now we want obtuse, not acute. So go back and think about your circles. If you have a sine value of 2/3, the calculator tells you that this angle right here is 41.8 degrees. Well, over in the second quadrant, you can also find a sine value of positive 2/3, and it would simply be 41.8 degrees less than 180 degrees. So this time we're going to say that angle B, is 180 minus that 41.8 degrees we had originally, which tells us that B is 138.2 degrees. Now that's completely different from what we had in the situation where we assumed that B was acute. So right now what we have is that angle A is 30, that angle B is 138.2 degrees, side A is 6, and side B is 8. Now for sure, angle B is the biggest. Well, let's calculate then what C would have to be, knowing that these add up to 180. And doing some calculations, you will get a very small angle for C, 11.8 degrees. It's actually smaller than angle A, isn't it? So let me just rearrange this in pieces. That's okay. Nope. This one. So then side C should be pretty small. Should be less than 6. And you can go ahead and do your law of sines on that. I will just write it out very quickly. Where you start out with angle A again. 11.8 degrees over C. And doing your calculations, you should get that C is about 2.5. Okay, that's really, really tiny. But it is another solution to what is given to us. So, in general, if you get to a problem where you are not sure whether the angle you're working with is acute or obtuse, the first angle that you find, for us that was B. Okay. This one, we don't know whether it's acute or obtuse. If that's the case, then you very likely have two different triangles. So the first time you go through the problem, go ahead and use your calculator like you normally do and get your acute angle, and then continue on with your last angle and finish off the triangle. Then you need to start over again, and really, honestly, you can start at this situation, this spot right here. That's where things start to go crazy, because then we start using the inverse sine. It gives us the acute. So instead of the acute angle, go ahead and calculate the obtuse angle that also has that same sine value. Take 180 minus the angle that your calculator gave you, then finish out angle C and side C. And that is how you find two unique or two different solutions. It's ambiguous, the ambiguous case.